Have you ever wondered how rockets work? Perhaps you've watched a space launch, marveling at the sheer power that lifts these colossal machines skyward. Or maybe you're intrigued by the intricate dance of physics and engineering that allows us to venture into the cosmos. Rocket science, often cited as the pinnacle of complexity, is the driving force behind these awe-inspiring feats. It's a world filled with propulsive forces, payloads, guidance systems, and structural intricacies. So, buckle up as we delve into the fascinating world of rocket science. Rocket science, in essence, is all about propelling a vehicle into space. But what's the science that makes this monumental task possible? Let's dive in. At the heart of rocket science is a fundamental concept from physics, Newton's third law of motion. You've probably heard it before. For every action, there's an equal and opposite reaction. This law is the driving principle behind rocket propulsion. Imagine you're on roller skates and you throw a basketball. As the ball moves forward, you'll be pushed backwards. That's Newton's third law in action. The same principle applies to rocket propulsion. The basketball here is the rocket's exhaust gases, and the U on roller skates is the rocket itself. In a rocket engine, fuel and an oxidizer are combined and ignited to create a high-pressure and high-temperature gas. This gas is then expelled out of the rocket's rear at high speeds. As the gas moves one way, the rocket is propelled in the opposite direction upwards and into space. But it's not as simple as throwing something backward to move forward. The power and efficiency of a rocket depend on the speed and mass of the exhaust gases. The faster and heavier they are, the more thrust they generate. This thrust needs to be greater than the weight of the rocket for it to lift off. Once in space, the rocket can maneuver by expelling gas in different directions. This is because, in the vacuum of space, the tiniest push can change a spacecraft's direction. It's all about using that equal and opposite reaction to your advantage. And what about reusable rockets? They follow the same basic principles, but with an added twist. After the rocket's payload is delivered into space, the rocket reverses its engines to slow down and guide itself back to Earth, where it lands vertically, ready for its next mission. And that's the science that powers these giant machines into space. At the heart of any rocket lies in its engine. This is where the magic happens, where raw materials are transformed into the thrust that propels these magnificent machines into the cosmos. But what exactly goes on inside a rocket engine? Let's dive in. A rocket engine is essentially a large, controlled explosion. The main components include the combustion chamber, where the explosion takes place, the nozzle, which directs the exhaust gases, and the propellant, which fuels the explosion. Now, this propellant is made up of two key parts: the fuel and the oxidizer. The fuel is the material that burns to release energy. Think of it as the rocket's food. This could be a liquid, like kerosene or hydrogen, or a solid substance. The oxidizer, on the other hand, is a chemical that helps the fuel burn. It's like the oxygen we humans breathe in to help our bodies break down food. In a rocket, the oxidizer can be a gas like liquid oxygen, or a solid chemical compound. Here's where it gets interesting. The fuel and oxidizer are stored separately in the rocket, and they're brought together in the combustion chamber. When they meet, they react with each other in a chemical process called combustion. This combustion produces hot gases, and lots of them. These gases expand rapidly and are forced out of the rocket through the nozzle, creating a force in the opposite direction. This is what we call thrust. The thrust is what propels the rocket upwards, pushing it against the force of gravity. The more thrust a rocket engine can generate, the faster and further the rocket can go. It's a perfect illustration of Newton's third law of motion. For every action, there is an equal and opposite reaction. So to sum it up, a rocket engine works by combining fuel and an oxidizer in a combustion chamber to create an explosion. This explosion produces gases that are forced out of a nozzle, generating thrust. The engine, through its fiery power, propels the rocket upwards and beyond. The structure of a rocket is a marvel of engineering. Just as the human body relies on its skeleton for support and function, a rocket's structure is its backbone, ensuring stability and performance under extreme conditions. At the heart of this structure are three fundamental systems: the payload system, the guidance system, and the propulsion system. Each serves a distinct purpose, and they are all interconnected in a complex symphony of engineering. First, let's explore the payload system. This is essentially the cargo hold of the rocket, housing the precious cargo that the rocket is tasked with delivering to space. From scientific equipment to satellites and even astronauts, the payload system protects these valuable assets from the harsh conditions of launch and space travel. Next up is the guidance system, arguably the brains of the rocket. This sophisticated piece of technology is responsible for navigating the rocket through the cosmos. It collects and processes a multitude of data in real time, adjusting the rocket's course as necessary to ensure it reaches its intended destination. Without the guidance system, a rocket would be like a ship lost at sea, incapable of finding its way. Last but certainly not least, we have the propulsion system. This is the powerhouse of the rocket, providing the necessary thrust to overcome Earth's gravity and propel the rocket into space. It's a careful balance of fuel, heat, and pressure, all working in harmony to create the explosive force that sends rockets soaring into the sky. Each of these systems plays a vital role within the rocket structure, contributing to the overall success of the mission. From the moment of launch to the final destination in space, the structural system of a rocket must withstand intense conditions, from extreme heat and pressure to the cold vacuum of space. Indeed, the structure of a rocket is more than just a casing for its components. It's a testament to human ingenuity and the relentless pursuit of knowledge, a complex machine built to withstand and conquer the final frontier. Each part of a rocket plays a crucial role in ensuring a successful mission. The advent of reusable rockets has revolutionized space travel. The dawn of the 21st century brought with it a game-changer in the world of rocket science and space exploration. Reusable rockets. These aren't your ordinary one-time use rockets. No, these are the rockets that have the audacity to venture into space, deliver their payload, and then return back to Earth ready for another journey. The magic of reusable rockets lies in their ability to land back on Earth after their mission is accomplished. Picture this: a rocket soars high, piercing through the atmosphere, and after detaching the payload, it doesn't just fall back to Earth in a blaze of glory. Instead, it gracefully descends, guided by precise navigation systems, and lands upright, ready to embark on another mission, given a little refurbishment and refueling. Now you might be wondering, why go through all this trouble? Why not just build a new rocket each time? Well, the answer lies in two words: cost and sustainability. Building a rocket isn't a walk in the park. It involves a significant amount of resources, both material and financial. So, if we can reuse a rocket, we save on those resources. It's like having a car that you can use over and over again instead of junking it after a single trip. Moreover, by reusing rockets, we're also making space travel more sustainable. The less waste we generate, the better it is for our planet. And the more missions we can undertake, the more we learn about our universe. To summarize, reusable rockets are a paradigm shift in rocket science. They have made space exploration more affordable and sustainable, and have opened up a world of possibilities. They've made it conceivable for us to think about things like colonizing Mars or commercial space travel. Yes, these are still in the realms of science fiction, but with reusable rockets, we're inching closer to turning them into science fact. Reusable rockets truly are a giant leap for mankind. Rocket science, though complex, is a fascinating field. We've traveled a long way in this video, delving deep into the principles that make rockets soar. We discovered that rocket science at its core is all about Newton's third law. For every action, there's an equal and opposite reaction. This simple yet profound principle is the driving force that propels rockets into the great beyond. We then turned our attention to the heart of the rocket, the engine. We dissected its intricate structure and learned about combustion chambers, nozzles, and fuel types, all working in harmony to generate the thrust necessary to overcome Earth's gravity. It's a symphony of science and engineering, each part playing a crucial role. Our journey didn't stop there. We explored the importance of a rocket structure, from the payload system that carries valuable cargo to the guidance system that steers the rocket on its path, and the structural system that withstands the rigors of space travel. And finally, we discussed the game-changing concept of reusable rockets. These marvels of engineering have revolutionized space travel, making it more affordable and sustainable, and opening up new horizons for exploration and discovery. Remember, every time you look up at the sky and see a rocket, there's a whole world of science and engineering making that journey possible.